Well, hello there. This is KP, the Math G, as you can see up here. Wearing a different hat than I normally do. I have at least 4 or 5 different caps here. So you may see me with a cap or a hat or something like that. So that's just the nature of me. So if you don't like my hat, fine, and if you like it, fine. It's okay either way. Alright, hopefully you like it though. Alright, we are talking about the derivatives of inverse trigonometric functions. This is part 1. Part 1 being that we are going to derive, not all of these, but 3 of the 6. And then on the next video, we will do some actual derivatives of these. Now, I do not know how many of these in the AP calculus there will really be. So I don't want to spend a whole lot of time on this, but I do want to spend a little time on it. I want you to know at least maybe how to derive something, and if nothing else, that's good practice anyway, to get where you can apply something and learn how to use it. Okay. If you notice over here on the left, I have all the derivatives here. I want to say that the most common one, now I have not taught in a few years, so, but from what I have gathered teaching before, that the tangent inverse has been the one that is used probably the most. And then again, it could be sine inverse. This is not the same as 1 over sine, which is cosecant. It's just sine inverse. Some people use arc sine, arc cosine, arc tangent, and so on. I will use these interchangeably on the next lesson, and I'm going to leave these up here. So what I want to be able for us to be able to see is that we do get the same thing. I want to derive this derivative here. So we can say that y is equal to the inverse of sine of u. And so what we can do is rewrite this as sine of y. Equivalently, we could say sine of y is equal to u, and actually if you look at it, it is u over 1. In pre-calculus, we know that that is opposite over the hypotenuse. And so over here, opposite of y is u, and then the hypotenuse here is 1. And that's really the best way to set it up. I put it in quad 1, and yes, there are restrictions to this. So anyway, I won't want to go over the restrictions. I know that the inverse of sine is from I know that sine, I just have to look it up again, but from negative pi over 2 to pi over 2, I want to say, I have to look this up, but anyway, that, yeah, I just have to look it up again, so please excuse me if I forget the restrictions. I do know that the graph of sine, that the range of sine is from -1 to 1. I know that. But as far as inverse, negative pi over 2 to pi over 2. But those are restrictions. But putting that aside for now, that's not quite as important as deriving this. It is important, but not as important at this point in juncture of our lesson. Okay, so let's look at it. I have a right triangle drawn here, and here's the opposite This is the hypotenuse. And then we want to find out what this is right here also, because we're going to take the derivative of both sides. So here we go. Let's call this C for now. I don't want it to be X or Y. We're just going to call it C. So we know that the square of the two legs, the sum of the square of the two legs equals the square of the hypotenuse. So we have C squared plus U squared is equal to 1 squared, which is just 1. And if we solve for C, we can subtract this U squared, so minus U squared on both sides. So what we have here is C squared is equal to 1 minus U squared. And then if we take the square root of both sides, we're going to keep the positive side of it. We're not going to do plus or minus, we're just going to keep the positive of that. So C is equal to plus the square root of 1 minus U squared. So we know that this part right here is the square root of 1 minus U squared. And that's always true. The hypotenuse squared minus one of the legs squared. And that's always going to be the case. If you have the hypotenuse, it'll be 1, or yeah, in this case 1 minus something. Okay, so we have all the three sides. Now I'm going to need to erase this. Let's go ahead. I'm probably going to erase more than that. May just have to put my figure up here and then go down this way. Let's do that. So let's draw it. I'm sorry I don't have a lot of room. Oh, I could flip it over, but that's okay. I just want to give you the idea. So we have this 1 and U, and then the square root of 1 minus U squared. Okay, actually it's 1 squared, but 1 squared is 1, so there it is. Okay, so let's keep that in mind as we do this, and I may do the other two that same way. Alright, so let's do this. Okay, so now what we have is sine of y is equal to u, which is u over 1. So I want to take the derivative of both sides of this. If I do that, then the derivative of sine is cosine. Now remember, we're taking cosine y, and then we got to take the derivative of y, which is 1 times dy over dx. So just get used to this. When you take the derivative of this, then you're going to just say dy over dx. Now that's equal to 1, just 1. Again, we're doing this with respect to y. Alright, so okay. We're going to divide both sides by cosine y. And so dy over dx is equal to 1 over cosine y. But now, let's take a look at that. Cosine y is, so 1 over, and then this is going to be, alright, cosine is adjacent over the hypotenuse. So that is the square root of 1 minus u squared over 1, which is really just equal to 1 over the square root of 1 minus u squared. And of course, if there is a derivative of u, which there probably will be, we do want to tack that on. So yeah, that is the final answer to this, and that's what I have here. I just derived that derivative. It would not hurt to memorize these. If you notice that the square root is used on sine, cosine, secant, and cosecant, but on sine and cosine it's 1 minus u squared. Notice cosine is negative. Everything with a c is negative. Okay. Tangent is 1 plus u squared. So is cotangent, but remember cotangent is negative here, so the negative is right here. Secant is the 1 over u, and then that is incorrect. This is going to be u squared minus 1, and not the other way around. It's u squared minus 1. Okay. I'm sorry, I just miswrote that. And again, the cosecant is almost the same except for the negative here. Okay. Always going to have a 1 in the numerator or negative 1. Okay, that's the way I do that. Okay, so we have derived sine, or the derivative of sine inverse. So let's look at another one. My eraser I have is supposed to stick up here, and I didn't do it a while ago. Now it's going to make a liar out of me. Okay, well, it's bad enough if a eraser makes a liar out of me. It's even worse if a person makes a liar out of me. So anyway, that was supposed to be funny, by the way. Okay, let's see. Oh, now you're confirming what. Okay, there you go. Okay, let's do tangent. Let's come up with that one, and I do want to do secant and show that that's. Okay, so let's do it again. We're going to take the derivative of tangent inverse. So we have tangent inverse of u. I want to, let's make this equal to y. Let's do it again. I'm sorry. Y is equal to tangent inverse of u. Now this again is u over 1. And if we write it over here, okay, like this, okay, remember opposite, this is opposite over adjacent, okay. Alright, so let's see, let's just go back over here, rewrite this. Tangent of y is equal to u, but u is u over 1. Alright, so opposite is here, here's y, I should put degrees there. So let's see, this is going to be u over 1, opposite over adjacent. And then we can use the Pythagorean formula to find out what c is. So 1 squared plus u squared is c squared. And then if I take the square root of c squared, I've got the square root of, so let's see, yep, that's right. So c is equal to the square root of 1 plus u squared. So right here, this is the square root of 1 plus u squared. Okay, that's what we have there. And all of this, somewhere down the line, you're going to have a square root of something like that. So just keep that in mind. All right, so we have those three there. And we're going to need that, okay? So let's see. Let's take this derivative of tangent. Now remember, the derivative of tangent, that's something else you got to know. You got to remember your derivatives of sine, cosine, tangent, and so on. The derivative of tangent is secant squared. Secant squared y times, now again, dy over dx. Derivative of u is still 1. So if we solve for dy over dx, we have secant squared y. Secant squared y. And sometimes if you want to, you can rewrite this as 1 over secant y, and then square the whole thing like that. That's the same thing as this. So either way, you can do that. And actually, if you think about it, 1 over secant squared is just cosine squared. If you want to look at it that way, that is cosine squared y. Now, alright, well, let's see. Cosine y squared. So let's see, here's what we're going to do here. In place of, we're going to replace this now. Cosine is adjacent over the hypotenuse, but now remember this whole thing is squared. So it's going to be, okay, so 1 over, okay, so let's see, I'm sorry, that is, yes, it is adjacent 1 over by the hypotenuse squared. So it's the square root of 1 plus u squared. But remember, we are squaring this right here. Okay. Now you know what a square does to a square root. It just simply knocks it off. So now we have this equal to 1 over 1 plus u squared. And again, u prime. That is the derivation. We derive tangent. Okay. Okay. And we could have left it as 1 over secant, knowing that secant is hypotenuse over adjacent is 1 over those. So we could do that and still get the same answer. Either way, it works out. Okay, there's that one. And then finally, I want to do secant. Okay. Again, you know, when all else fails, you can always derive this. Of course, if you're taking a test, it's just better to memorize this. You know, I'd keep this to memory, commit this to memory, and that way you don't have to worry about deriving it. But one thing about it, if there's some reason you cannot seem to memorize it, you can derive it. Okay, that's one thing you can do. You can derive it. Let's do this one now. Let's go again. Alright, like this here. Alright, so let's see. Secant. Secant. So y is equal to secant inverse of u. Okay. Again, secant, S-E-C. Oh my goodness, I did sine, didn't I? Okay, now we've got it right. Okay, secant inverse, and then now the secant of y is equal to, oh, well, let's see, it's u over 1. Now remember, this is, well, that's the reciprocal of secant is cosine. Remember that cosine y would be 1 over u. Secant is u over 1. This would be adjacent over the hypotenuse, whereas this one would be then the hypotenuse. So u would go here, and adjacent would go right here. And, of course, if we did the arithmetic on this, we would find this to be the square root of u squared minus 1. So if we made this c again, so 1 squared plus c squared is equal to u squared, and then solving for c, this is still 1, so minus 1 on both sides. You see what's happening here. This is u squared minus 1. Take the square root of both sides, and c is equal to the square root of u squared minus 1. Okay, so we want that. Alright, we want to figure that out because we want to see, we might need to use it, and I have a feeling we will. Okay, so let's do the arithmetic here. We don't need this. Okay. I hope that you can see me okay. I feel like the camera's pointing more this way than it is over here too, but alright. Alright, so let's go ahead and take a look at this one now. Let's see, the derivative of secant now is secant tangent. That's one thing you just have to remember. You got to know your derivatives of the trig function. So secant y times the tangent of y dy over dx. Derivative of u is just 1, okay? And if you wanted to put, u prime, you can, it's okay. But anyway, derivative of u is 1. Okay, so what we're doing here is we're dividing both sides by secant y, tangent y. This side over here, let's move this 1 over. Secant y, tangent y, and this divides out. And so now we have dy over dx equal to 1 over secant y, tangent y. Now we want to replace that with this over here. Okay, that's what we're doing now. Okay, so let's see. Secant is, remember, the hypotenuse over the adjacent. Alright, so this is the hypotenuse, this is adjacent, this one is opposite. Okay, so the hypotenuse over adjacent is u over 1. Alright, so now it's 1 over u over 1, which is just u. Okay, and then the tangent is opposite over adjacent, so the square root of u squared minus 1 over 1 is just the square root of u squared minus 1. And remember to just tack on the u prime at the end. You'll see the need for that definitely when we get into our next video. Well, the other three can be done the same way, and even if I did just one, you could do the others if you just knew how to do one, but I felt like this was what you needed to have. I mean, after all, sometimes if you forget, if you can remember to do this, you can certainly derive the formula for this. You can derive the derivative. Okay. Like I said again, it does help to memorize. The only one without the square roots are tangent and cotangent, and that's the only one that has the plus sign. You could have said u squared plus 1 here. It does not matter. Once again, sine and cosine, 1 minus u squared. Okay, the cosine is going to be negative. Okay, cotangent here is negative here on this one. Here again in the denominator, u square root, and just put the u. I just memorize. I have a u, and we'll start off with a u squared in here. So u squared minus square root of u squared minus 1, and then all of these have the u prime at the end. Okay, and same thing here, u square root of u squared minus 1, again negative 1 here. So negative for all the c's, and you notice that right there. So again, I would say commit these to memory, but there again, it does help to know where they came from, and that is one important element in the study of mathematics. Where did it come from? How did you derive that? Did we just snatch it out of the air? No, we didn't. We came up with a plan. We came up with the derivation. Okay, so that's it for today. Again, this is KP the Math G. We will do part 2. Remember, next time part 2 will be actual finding derivatives of these trig functions, and again we'll probably do 3 or 4 quick examples, and it will not take long at all. That next video shouldn't take too long at all. I believe this is video number 19. The next one will be video number 20. If there's a subscription, press that, subscribe to me. I don't know if you have that or not. Anyway, KP the Math G signing off. Have a great day.